So our group name is the Math and Computing or Analysis, Relevance, and Engineering. The group members are Paul Rivolo in CS at Olin, myself, Carl Laird, in Chemical Engineering at Purdue, Sam Tyra is in Mechanical Engineering at Florida State, Chris Wilson is Mechanical Engineering at Tennessee Tech, and our beloved orange dot was Brian Scrum at ECE at Arizona State. Some of what you're going to see is a bit similar to the last group, and so we saw a lot of similarities, and I'm sure we had some similar discussions. So I want to invite the members of that group to try and catch up with us at the break and let us share some ideas. So our team lamented the fact that student skills in numerical analysis and programming are declining. In fact, with the introduction of quality engineering software, a lot of programs, in particular in chemical engineering I've seen and in others, are actually reducing the requirement for programming and numerical analysis, which seems strange to us. I think this move misses two facts. The first is that engineers are needed to create this quality software, and the second is that a lot of other classes can benefit from experience in these analysis tools. And so our discussion focused on techniques to better teach and integrate numerical analysis and programming in a way that is kind of fun and motivating for students. As we were nearing the end of our time, we realized we'd done a lot of discussing and not very much slide creating. And so we got a little nervous and quickly realized to better focus, we also had to quickly find a fun way to motivate ourselves to actually get down to preparing our presentation. And this was motivating for us.
Hello, Professor.
Hello.
I do not know how to solve problem 5. Can you tell me how to solve problem 5?
Did you derive the differential equation?
I took differential equations 4 semesters ago. Why do I have to do them again?
You need to write the differential equation and solve it using the Runge-Kutta method.
What is a Runge-Kutta method?
You should have learned that in numerical methods.
I never saw that in numerical methods. In fact, I no longer have my numerical methods textbook.
The Runge-Kutta method is a numerical method for solving a differential equation. This method is built into MATLAB.
Wait, MATLAB? Does that mean I have to program?
Yes, you should program the solution to problem 5 using MATLAB.
I already passed the programming class. I don't understand why I have to program again.
The point of us requiring you to learn how to program was so that you could use it in your engineering classes.
I thought the point of learning to program was so that I could get a high-paying internship. Also, why do we have to use MATLAB? I heard Python is totes better.
Frankly, I am shocked that you did not learn anything of value from these previous classes. I wonder what my colleagues in the math and computer science departments are doing. Hey Bob, how is your semester going?
Hi Andrea. I am doing pretty well, so far. Can you believe it is midterms already?
Hey Bob. Not really. I just met with a student that I have never seen before. He is in my process controls class. I am concerned because he does not understand some fundamental things, like differential equations and how we transform them into algebraic equations. He also gets confused about the difference between definite integrals and indefinite ones. His answers are always indefinite.
I see this problem all the time. I am not really sure why, because the students take 20 hours calculus, matrix algebra and differential equations. The math department teaches them all this material, so why don't our students just instantaneously have the math ready to use?
You know that our students have short memories and need to practice. A lot. A whole lot. A really whole lot. You work 5 problems, you are novice. You work 10 problems, then you are proficient. You work 20 problems, then you are an expert.
I may not be an expert myself, but I try.
I guess we have a lot to learn about connecting the important details in our curriculum together. Alex over in electrical just came back from a conference. I think it was the FOEE Symposium in California. He learns a lot of strange ideas about collaboration and active learning and things like that. Maybe we can talk with him some about what he learned. He is giving a talk for the electrical department faculty next week.
Andrea, let's talk with him after that. But don't forget, Alex is the guy that used to use Fortran and MS-DOS.
Hey Alex. We enjoyed your talk. Bob and I would like to see if you can talk to our department.
Hi Alex. Yes, we would like to come after our MATLAB session for new students.
I recently attended an education conference sponsored by the NAE. We discussed many of the same issues. We have outsourced many key classes and there are not many connections linking these courses to the engineering curriculum. We discussed several ways to integrate engineering problems into these courses. As well, we all agreed that many students are scared of programming. We discussed several ways to get them excited about programming and see the value of these courses. We decided to start a collaboration to build fun modules in Python so students could program games based on engineering principles and models. This is an entertaining way to teach the value of simulation. We could even have students design and build children's games for K-12 outreach. We also discussed the use of new software tools to provide immediate feedback for students learning the basics, like Python Notebook, Pithy, and Xcode playgrounds. Furthermore, companies need engineering students with software skills, numerical methods, advanced programming, simulation skills, and software validation and verification are becoming even more important. We decided to gather data on employment numbers in engineering software careers. We hope these techniques will help make students excited about programming and numerical methods, to better prepare them for future classes, rewarding careers, and eventual nomination to the NAE.
So maybe a round of applause to Paul for compiling
Hello,
that.
Professor.
Hello.
I do not know how to solve problem 5. Can you tell me how to solve?
So, so to sum up some of the key points that we discussed, there are 4 points that we think were quite important. First of all, we believe that we sort of outsource some of these critical fundamental classes outside of engineering. So, for example, mathematics or computer science courses, we kind of let other departments teach it, but perhaps we can sort of actively get involved in what they should cover. For example, provide examples that are more related to engineering applications, like what they were talking about in the previous talk. Students seems to be very fearful of mathematics and computer science or programming. I think that can be removed by perhaps using these latest tools that we discussed that can provide instant feedback so we don't let the students go home and do their homework kind of in a confused state of mind. We decided that we're going to be collaborating and developing materials, especially in terms of assignments and projects, especially those that could be fun. Some of the things that we talked about were engineering-based game development using simple coding. Hopefully that'll sort of keep students engaged and interested and know how to use programming more in terms of the engineering context. And at last, we're going to be developing a curriculum or electives to prepare students for their career in engineering with the mindset or the objective to make them more sort of ready for career where they use software or develop software. Because we strongly believe that the use of computer is just another set of tools, just like what you see in experimental methods. I think it's just a counterpart to that. So I believe that's going to be seen more and more in the engineering sort of discipline. So I think this is a critical part. With that, I think we'll be happy to take any feedback or comments. Thank you.
We selected those characters because they were a lot more animated than we were. So.
All right, time for a couple questions.
I loved the message, but could you make Alex a little bit less boring? Because, I mean, no wonder those 3 guys are not reaching anyone. Alex was even more boring than I.
So my name is Matt Cooper. I'm from NC State. At the risk of sounding foolish, I did not have a very good understanding of math whenever I graduated with my BS. I went to grad school and realized I needed to really know my math. And it might sound ridiculous, but I had a hard time understanding the way that my math professors would teach math because it was all dy dx, but I was needing to learn things like DC, concentration over time, and it was really difficult for me to make that conceptual shift. So I do think that there is a disconnect between the way that the math department teaches math and the way that engineers use math. And that was hard for me to overcome. It took a lot of effort on my part to do that. So I do think it's something that we need to consider. Perhaps teaching math more as an applied math for engineers, if you will, but by an engineering professor, not necessarily by a math professor. I think that mathematicians just look at things a little differently than an engineer might.
Hi, I have a question either for you or anyone else. I think we've all had this problem in our classes. I'm now trying to fill in some holes in statistics from students in my measurements lab. So I'm unsure of what to do. Should I just review everything at the beginning? Should I let them review the material on their own? I mean, I don't know. I'm trying different things. I'm still not sure what works. So if someone can share what you've done with a problem like this and if it's worked, it would be great. Thank you.
Oh, I can say what I do in my class. So I spend the first week of the class basically reviewing physics and biology. So reviewing all of freshman physics and then reviewing biology, and then I have a monster homework assignment that goes over everything. And the students know that they will not be explicitly tested on that material. In other words, there's going to be a test on the midterm on like Newton's laws, but that in order for them to do well in the class, they better understand all of that material. And so if they have questions, they should come to office hours. But the first homework assignment it's a book. Like it is the equivalent of 3 semesters of material. But theoretically, that's the classes. So and I posted it online like 4 weeks before the semester started. So they can start it early. And again, they've already taken the class, so they should be able to do it without me.
So let me briefly mention, I don't do that, but what I do is the first day of class, we have a group activity where I might take the pertinent parts of the prerequisite final exam, and I'll just call it quiz 0 and tell them, hey, this is the stuff I wish you knew. And whatever it is, whether it's math or whatever it is, we kind of go through it in that vein. And I think that's helpful because, first of all, when you deal particularly in the ABET, the accreditation world, and you look at the outcomes that our math colleagues will put on an ABET course syllabus, I teach design and some modeling, and I might have 4 outcomes for a course. Well, they'll write down 14. Because everything's an outcome to them. And trying to distill that is a very difficult thing. So the idea, I think the first day is great, maybe not a year and a half's worth of stuff. But.
one comment, I think there's a lot of potential there for intelligent tutoring software to be helpful in doing some of this math review. That there's a lot of good math software out there. Now, some of it doesn't go high enough, it doesn't go up into calculus or differential equations, things like that. But I think as time goes by, that can be a very efficient way for people to review and do so, outside of class without having to necessarily give them a gigantic homework assignment.
Following up with that comment, I realize time is always an issue, including now. But I think it would be a great idea for engineers to co-teach some of those classes with people in those departments, and I think both sides would learn a lot about the challenges. I also think it's very important not to explicitly trust the students when they say they've never seen something before.
All right. Let's, I think we need to wrap it up here, so thank our group.